So to start, let me show you what we have as far as setup. We have a Huntron Access Prober. We have a circuit board mounted in the back right corner, separated from the back wall by 2 board spacers, and a board spacer on the right-hand side as well. We need to get the board out away from the wall so we can probe to the edges. We've also got a crossbar here that's holding up the front edge of the circuit board, and an end slide that holds the board in from side to side. If we look at it down low, you can see the board is mounted at the middle slot, meaning that we have a top, a middle, and a bottom slot, and we're mounted at the middle slot. We've also got a small video microscope set up here to help us later on when we go through our offset steps. In Workstation software, we'll start by adding a new board database. To do that, we'll use the button to create a new board. In the name field, let's type in test demo board number 3. We'll be using microns as our units of measure. That's the distance that the prober will be moving with. And click OK. We'll save that to our computer. The next step would be to add a sequence to this database. To do that, we'll use the Add New button. Type in a name. Let's call it top side, meaning that we're going to be probing the top side of the circuit board. And then under the slot, we'll be selecting middle slot. Of course, that's where the level that the board is mounted at. And then click OK. So that will add a sequence to our database. And then the last step, we'll add some components to this sequence. You can see it's empty right now. We'll start by adding the first of 3 components. We'll start with component U28. This is a small QFP device. So in this case with Workstation, this would be called a multi-package. I'll hit the letter M on the keyboard to select multi. That means it's multi-road or multi-sided. We'll tab down, type in the number of pins on this device. It's got 16 pins on each side, so that would be a total of 64 pins. And then down, we'll type in the pin spacing. This one actually is spaced at 800 microns or 0.8 millimeters. We'll click OK. You can see that component added to our sequence. We'll add one more component. This one will be a dip package, a little 8-pin dip called U71. Tab down to the package type. You see it's already selected for dip. And we'll type in the number of pins, 8 pins. The lead spacing on this one is 50 mils, which translates to 1,270 microns. And we'll also add a 2-pin device. In this case, we're going to be adding C3. This is a probe package, a little bit different than the others, and has 2 pins. In this case, the pin spacing does not matter. Click OK. So we've got these 3 pins, or these 3 components added to our database. Now before we can use the prober to accurately probe devices, we need to do what we call offset. And what offset is, let me grab my camera. You see the probe tip is right here, and the camera is to the right over here. So the software needs to know the distance between where the camera is looking to the probe tip. It needs to know this relationship distance. That way, when we teach a component location with the camera, we can put the probe precisely on that same point. So to do that, we use this offset tab in the prober pane. Let me enlarge this. Let me move it slightly to the right. There we go. And camera selected, so we'll move the camera out over the circuit board. I can either click in the image or use these arrow keys to move larger distances. So I'll start with that. And I've picked out a spot on the forward edge of the board. Here's my target right here. I'm just going to go right for the center of the R. That looks pretty good. So I'll set that as my camera position and then switch from camera to prober. You can see in the background the prober moving around. So what we want to do is put the probe tip on that same location. So let's redock this window. And what I'm going to do is switch over to my other camera. So go select and select the microscope and start that one. So you can see the R153 stenciled there. And I'm going to move the probe down now. So we'll move it down to some large steps to start with. And momentarily you'll see the probe tip come into view as I lower it down. We want to have the probe tip just make contact with the surface of the circuit board. So it looks like it actually is touching now, so let's lift it up some. Okay, you saw it just lift. Let's kick it back down, and now it's just making contact. You can see that it's not on our target, so we need to move it to the left. So to do that, we'll use the arrow keys. I'll go 100 microns at a step, and the probe will lift as I move it sideways. So it'll take me several clicks to get this over on the target. We want to get it precisely on that same target that we selected with the camera. And one more click. That looks pretty good. And just to make sure, I'm going to look at this from a slightly different angle. And it does look pretty good. So we'll go with that position. We'll set that and then save. The offset is saved in the registry of the computer, so this is a setting that is used for any test that uses the middle slot. All right, so I'm going to switch now back to our other video camera. That is this USB camera. Okay, and start that one. There we go. Now, as part of the actual board test, we will select 2 alignment points on the surface of the circuit board to use for positioning the board within the prober bed. My first one is a small via towards the back edge. And then it's right down in this area here. I'm clicking in the image now, and this is the point that I selected, this small via. And we'll make a small step here. Move 30 microns on my arrow keys. And that looks pretty good there. So we'll select alignment number 1. It's telling us to mount the board in the middle slot, which we've done. And I do like the position, so I'm going to set that. Notice that the software automatically incremented to alignment number 2. So I have a small via in the front left corner of the board that I've selected, so let's move the prober to that position. We'll try 50,000 microns and move forward and left. And then I'll try like 10,000 microns. You see it come forward some. And this is the point right here that I was thinking of. Let's take a look. And that does look good. The alignment points also, it's helpful if they kind of sit off by themselves, if they don't have a lot of other things around them. This will work well with our auto align function that is built into the software. So that position looks good. We'll set that and then save those alignment points. So when we save these, we also captured images of the alignment points within the database. Those stored images will be used later on as part of the auto align function. Now we can move forward with creating a board image. So that it happens down here in the image pane. So I'll stop this video feed, switch to the image tab. And what we do is we select a front left corner boundary of the board and then a back right corner boundary of the board. And between those two boundaries, we will capture a whole series of images using this main camera. And then we stitch those images together to form a board image that's displayed here in the image pane. So here's roughly the front left corner of the board. We don't have to be exact. So we'll set that as front left. And now we'll navigate to the back right corner. I'll move to a larger distance here. And then click to the right. I'm getting pretty close. I'll just click now in the image to move to the back right corner of the circuit board. So there's the connector along the edge. And so if I select a point right out in here, we've roughly got the whole board encompassed within our 2 positions. So we can set that as the back right position. And now we have a create image. So if you click the create image button, then the process will start. You can probably hear the prober moving in the background. I'll show some video of it doing it here. So that process is complete, and you can see that we now have an image of the circuit board in the image pane. If you were to zoom in on this board, you can see within the image, you can just see the stitching marks between each of the images that were captured with the main camera. So we use this primarily as a navigational tool to move the camera around up here in the Teach tab. So notice if I click in the center of this large component, that my camera goes to that location. So now the next step will be to teach the location of the components that we added to our database. We will start teaching the component locations at the top of our list with U28. Switch over to the Teach tab in the Prober pane and select pin number 1. Then use the board image to navigate the camera to the first pin of the device, and so that is right in this area here. You can see how useful this board overview image can be. Enlarge the Prober pane, and now I'm going to get centered in on pin number 1. This is the beginning of the first row of this component. So once we get that centered on the first pin, we'll save that. And based on the pin spacing that we typed in earlier for this device, the software is automatically able to calculate the distance between this first pin and the last pin of the row. So if you hit the left arrow key, the crosshair should automatically go there, and it does. So we'll save those 16 pins as a group. Notice that the software now has incremented the pin to 17 for us. So now we'll go ahead and click over to pin number 17, and that position looks good, so we'll save that. The distance here should be correct, so we'll move forward one click, and that position looks good as well. So we'll save that group of 16 pins. And now let's move to pin 33, the beginning of the next row. Now I don't have to use these arrow keys to move to the end of the row. I could save this and then click in the image and move to that last pin of the row myself, and then save those 16 pins as a group. Save. Of course, that takes a little bit longer, so we'll use the arrow keys to do this for us. So again, we'll get centered in on the first pin of this last row, save that, and then just use the up arrow key to move to the end of the row. And that looks good, so we'll save those 16 pins. So now U28 is complete. We'll use the next component button to move to the next component. See in the background here how it incremented to U71 for us. U71 is a small 8-pin dip located on the front edge of the board here. So we'll click in the board image, and here's U71. So this is already selected to pin number 1 for us. So we'll go ahead, line up on pin number 1, save that. This distance here should be correct for us, so let's use the forward arrow key to move to the other end of the row. Save the group of 4 pins. Now it's incremented to pin 5 for us. We move to the opposite side, pin number 5. Okay, that looks good. We'll save that, and then use the back arrow key to move to the end of the row. And that looks good, and we'll save that group of 4 pins. And then lastly, we'll do this C3 2-pin component. Now this is a probe package, which means that we have to teach individual pins on their own. So I'll use again the board image to click and get the camera near C3. And there's C3. I'll go ahead and put pin number 1 up here at the top. And that looks good. We'll save that position, and then we'll increment ourselves to number 2. Go down to pin number 2 of this device. We'll move it slightly lower. That's good, and save that. So that's how you teach the component locations in 3 different package styles: a multi, a dip, and a probe package. The next step would be to teach the up and down position of the probe itself. So to do that, I'm going to again go back to our live cameras and select our video microscope. And start that. And I'm going to use U28 as our teach height position. So we'll go here to select U28, and this front edge right here of U28 down in the video image, the far right pin is number 48. So we'll select pin number 48 in the Teach Height tab. So we'll switch to the Teach Height tab, select pin number 48, and even though you can't see it, the probe tip is now sitting over pin number 48. So what we do is we set an up and a down position for the entire sequence, meaning that I'm going to teach the up and down position for all of these components at one time. The reason we do it that way is because the probe position for all these components is at the same level. So to start, we'll lower the probe tip down to our up position. I'm going to adjust my camera here just a little bit. There we go. And lower the probe tip downward. You'll see it come into view here. Now we want to make sure the up position is high enough to get over the tallest component we're actually going to probe. And that looks like a pretty good position. We're about maybe 1/4 of an inch above the surface of the circuit board right now. So we'll save that as the Z up position for the sequence Z up. Save. And then lastly, we'll lower the probe tip downward to make contact with the circuit board. So I'm going to change to a smaller increment here and then gently lower the probe tip down. Notice how it's coming right down on pin number 48. Provided your offset was done correctly, this probe should go exactly where you teach it. Notice that it just as it made contact, we got a signature over here in the signature pane. So that's good, but I want to give it just a little bit more compression downward, so we'll click down one more time just to put a little bit of force on the probe tip. And then save this as the sequence Z down. That means this will be the down position for all the components in the sequence. So now we're actually ready to go and scan this circuit board. I'm going to move the probe to the up position. Now we'll go to the signature pane. Before I do that, we'll go back to our live camera, and I'll stop this one, and we'll go and select our webcam and start that so you can see the probing taking place. Go to the Scan tab. You just have to type in the serial number. Generally, we start with a known good board first, and we want to scan a known good board, get the signatures from that to store into the database. And then click Start. It'll give me an instruction window. If I had instructions in here, it would be displayed right now. We'll click Scan Sequence and let the prober do its job. I also want to show you a close-up view of this as well. You can see the probe coming down to each pin. We're scanning at roughly 1 pin per second in 3 tracker ranges. You'll be able to see it really clearly here as it comes to the front edge of the device. U28 is complete, so now the probe will go over to U71, probe that device. And then lastly, jump over to C3 and test both pins there. The test result comes up no ref. That means that there's no reference signatures stored into this database to compare to. So if we click the Troubleshoot button, one thing to notice is that we had an open on U71. We also had an open on C3. I happen to know on U71 this pin actually is a no connect, but on C3 we're concerned that we had no signatures here. We have an open indication, so what we'll do is go ahead and reprobe those pin signatures. So by right-clicking and selecting reprobe pin signatures, we now have a set of blue signatures that indicate that we actually got contact the second time we scanned it. So we'll select yes to replace those old signatures with these new ones. So that's a quick way you can go and fix any bad contact issues within the software. All these signatures look as they should. So what you can do now is set these as a reference. These now become the signatures that the software will compare to when you scan subsequent boards. Okay, now I've gone and placed another circuit board in the prober bed. So since I pulled one board out and put another one in, this one that I put in is a bad board, I want to be able to scan this circuit board and compare it to the reference signatures that we just stored from our known good board. So before I can do that, I need to do an alignment because the board position that I just put in might be slightly different than the one that we pulled out. So to go to the align, in this case I'm going to use the auto align function. And what auto align will do is it'll go out to where I originally taught the alignment points and then search around looking for the alignment point. If it finds it, it will try to line up on it automatically by comparing to the stored image that was captured during the first alignment. So that one's done. Now it goes to the second one. Okay, looks like it got the second point. Notice at the top here it says aligned. That means that it was successfully able to align comparing to the stored images. So now we're ready to scan this circuit board. I'll give it a different serial number. Let's call it 002. And again, we'll run the same sequence that we did on the first board, but this time it will compare against the stored reference signatures. So scan sequence. So now you see the probe starting. For the sake of time, I'll go ahead and stop my video capture now, and then we'll come back when the scan is almost complete. Okay, we're back. It's almost done scanning U28. It will now go over to U71. And then lastly, it will move over to C3 and scan those two pins. So now our scan is complete and we get a test result. Note that it says failed. At this point, we will click on the troubleshoot button and we'll be presented with our failures. We undock this window, make it a little bit larger. There we go. You can see the primary difference here is on pin 8 of U71. We had a resistive signature as the green signature, which is our good reference signature. That green signature was captured from the good board. And on this board, we notice that the resistance is no longer there. As a shortcut, what I can show you is we can go and do a get signature on that. Notice the probe goes down to it. But more importantly, we have the camera will go and put the camera above will now be showing on pin 8 of U71. And if we look at the trace coming off of pin 8, we notice that there is a resistor missing right in this area here. So if we trace it down, there's the trace coming off of pin 8, and you see there's a missing resistor. And that's what the signature is showing us, that the resistance that should be there is no longer there. We also have some differences on U28, but these are probably very small. We probably had a little bit of a charging difference there. So our primary problem here was U71. So we'll stop our demonstration there. If you have any questions, please contact Huntron. You can email us or call us, and we'd be happy to hear from you. So thank you for watching.